Welcome to ZeroEmbed, an AI automation agency focused on custom AI apps, workflow automation, and content systems that save real time. In this video, we are stepping away from hype and explaining one of the most important topics in technology in a clear and practical way. What exactly is artificial intelligence? How did it evolve, and why is it shaping so much of the modern world? Before we go deeper, here is the question for you. Which of these is the best definition of artificial intelligence? Option A, a machine that only looks human. Option B, a system that can analyze information, learn patterns, and perform tasks that usually need human intelligence. Option C, software that only works on the internet. Or Option D, a machine that already thinks exactly like every human. Pause for a second, choose your answer, and write it in the comment section before we continue. By the end of this video, you will understand the history of AI, the major shifts in its evolution, the types of AI people refer to, the core components behind modern systems, and the way AI is already affecting business, education, software, healthcare, and daily life. We will keep the explanation beginner-friendly, but still grounded in real concepts. After the question, we will walk through the history of AI, the transition from rule-based systems to machine learning and deep learning, the main types of AI, the ingredients every useful AI system needs, and finally what AI looks like in the world right now. To understand what AI is today, it helps to see where the idea came from and why progress did not happen in one straight line. The roots of AI are older than the term itself. Long before modern chatbots and image generators, scientists were asking whether reasoning could be described formally and then reproduced by a machine. In 1950, Alan Turing proposed a famous test for machine intelligence, not as a final answer, but as a way of framing the question. A few years later, in 1956, the Dartmouth workshop gave the field its name. The basic hope was bold. If intelligence could be broken into logic, memory, search, and decision-making, then perhaps software could reproduce some part of it. The first wave of AI produced real results, and that created enormous excitement. Programs could solve puzzles, play controlled games, and reason through carefully designed problems. These systems were impressive because computers were no longer just calculating numbers. They were following symbolic steps that looked a little like problem solving. But there was an important catch. Most early systems worked only in narrow, simplified environments where the rules were already known. As a result, expectations rose faster than the actual capability of the technology. AI then ran into one of the biggest lessons in the history of technology. It is much easier to build a system that works in a laboratory demo than one that works in the real world. Human language is ambiguous. Everyday situations are full of exceptions. Common sense is hard to encode as a giant list of rules. As the limitations became obvious, funding and excitement cooled. These slowdowns are often called AI winters. Later, expert systems brought momentum back by encoding specialist knowledge for domains like medicine or diagnostics. But they still depended on manual rule building and constant maintenance, so their scale stayed limited. AI returned strongly when three things came together at the same time. First, the world started producing huge amounts of digital data. Second, computing power improved dramatically, especially with graphics processors that could train large neural networks. Third, the field shifted from manually writing every rule towards systems that could learn statistical patterns from examples. This is why the modern wave of AI feels so different. Instead of programming every answer by hand, we train models to detect useful structure in large amounts of data. That change opened the door to image recognition, speech systems, translation, recommendation engines, and later generative AI. The next big question is not only when AI changed, but how the core approach itself evolved over time. One of the clearest ways to understand AI evolution is to compare rule-based systems with learning-based systems. In symbolic AI, humans describe the logic. The machine follows it. In machine learning, humans provide data, objectives, and training methods. The system then discovers patterns that help it make predictions or decisions. This matters because many real-world problems are too messy for a perfect rulebook. Think about recognizing faces, forecasting demand, filtering spam, or understanding customer intent. Learning-based systems work better there because they adapt from examples instead of waiting for a human to define every possible condition. A useful mental model is to see AI as an evolution ladder. First came systems driven mostly by rules and symbolic logic. Then came statistical machine learning, where the system learned useful patterns from structured data. After that, deep learning pushed performance higher by using multi-layer neural networks, especially in vision, speech, and language tasks. Foundation models then introduced a new scale of pre-training, where a single model could learn broad capabilities before being adapted to many downstream tasks. And now we are seeing agentic systems, which combine models with tools, memory, workflows, and decision loops to take multi-step action. Modern AI feels different because the user experience changed along with the underlying technology. Earlier AI often stayed behind the scenes. It ranked search results, recommended products, or filtered transactions. Today, people can talk directly to models in natural language, generate content, analyze documents, and connect AI to business workflows. The transformer architecture, larger datasets, better training methods, and accessible APIs all helped. So when people say AI is suddenly everywhere, what they usually mean is that capability, usability, and distribution arrived together at the same moment. The phrase AI is used in many ways, so it helps to separate the theoretical categories from the practical ones people use every day. A classic classification divides AI into ANI, AGI, and ASI. ANI means narrow intelligence. These systems are built to perform specific kinds of tasks, even if they can perform those tasks very well. Recommendation engines, fraud detection models, speech recognition, image classifiers, and large language models in practical deployments all fit into this broad narrow category. AGI is a theoretical idea of a system that can understand, learn, and adapt across domains with the flexibility of a capable human. ASI goes even further and refers to intelligence beyond human capability. For now, the world runs on ANI. That is important, because people often confuse impressive behavior with true general intelligence. In practice, teams often classify AI by what it does instead of by philosophical labels. Some AI is reactive. It takes an input and produces an output with little memory. Some AI is predictive, where the main job is forecasting or classification. Some AI is generative, where the goal is to create new content like text, images, summaries, voice, or code. And some AI is becoming agentic, which means it can plan a sequence of actions, use tools, check results, and continue until a task is complete. This practical view is useful because it connects AI directly to real business use cases. Another practical way to understand AI is by the type of information it handles. Text systems read and write language. Vision systems interpret images or video. Audio systems listen, transcribe, or synthesize speech. Multimodal systems combine several of these at once. This is why modern AI can take a screenshot, read a PDF, answer a spoken question, generate an image, and trigger a workflow through software tools. The core idea stays the same. AI maps inputs to useful outputs. But the type of input and output can vary dramatically. Now let us break AI down into the components that actually make a system work. No matter how advanced the final product looks, every useful AI system depends on a few core building blocks. It needs data to learn from or operate on. It needs a clear objective that defines success. It needs algorithms and model architecture. It needs computing power for training or inference. And it needs evaluation and feedback, because performance without measurement is just guesswork. Here is the simplest possible pipeline. First, you collect raw data. Then you clean it, structure it, and sometimes label it. Next, you train a model or adapt a pre-trained model for your use case. Once deployed, that model runs inference, which means it produces predictions, classifications, recommendations, or generated content on new inputs. After that, feedback matters. Human review, user outcomes, testing, and monitoring all help improve performance. This is why successful AI is not only about having a smart model. It is also about having a reliable system around the model. If you want AI to be useful, start with the problem before the model. Ask what decision, task, or bottleneck you are trying to improve. AI works best when the job is specific, the data is relevant, the outcome can be measured, and the workflow includes checks for quality. This is also where many companies go wrong. They chase a trendy model before defining the operational use case. In reality, a well-designed narrow AI workflow often creates more value than a flashy demo with no process around it. With that foundation in place, let us look at the current world scenario and why AI now feels impossible to ignore. AI is already part of the current world, even when people do not notice it directly. In business operations, AI reads documents, classifies tickets, drafts responses, extracts information from emails, and automates repetitive actions across tools. In software, AI helps write code, explain codebases, generate tests, review pull requests, and speed up debugging. In healthcare and finance, it assists with pattern detection, prioritization, forecasting, and risk analysis. In education, it supports tutoring and content adaptation. And in media, it powers search, translation, summaries, voiceovers, video generation, and content production pipelines. The current world scenario around AI is exciting for a reason. AI can help teams move faster, serve customers more consistently, work across larger volumes of data, and personalize experiences at scale. But the risks are just as real. Models can be confidently wrong. Training data can carry bias. Outputs can expose sensitive information. Overautomation can create mistakes at speed. That is why mature AI adoption is not about blind trust. It is about designing human review, access control, logging, monitoring, and clear limits for where the system should or should not act on its own. It is also important to say clearly what AI is not. AI is not magic. It is not wisdom. It is not perfect reasoning. And it is not a substitute for accountability. A model can generate a fluent answer and still be wrong. A workflow can be automated and still be badly designed. AI becomes valuable only when it is attached to real business goals, real data, and a process that checks whether the output is actually useful. This is why thoughtful teams treat AI as leverage, not as an excuse to stop thinking. The smartest way to adopt AI is usually not to automate everything at once. Start with processes that are repetitive, high volume, and easy to measure. For example, summarizing support tickets, extracting information from forms, drafting follow-up emails, classifying leads, or generating first-pass content. Then add human review where mistakes would be costly. Over time, you connect the model to tools, databases, and workflows so the output leads to action instead of just producing text on a screen. That is where automation agencies like ZeroEmbed fit into the picture, by turning isolated AI capability into dependable business systems. We have covered a lot, so let us end with the simplest possible recap. Here is the full answer in plain language. Artificial intelligence is the field of creating systems that can perform tasks usually linked to human intelligence, such as understanding language, recognizing patterns, making predictions, generating content, or helping make decisions. It evolved from rule-based logic into learning-based systems that improve with data and scale. Most AI in the real world today is still narrow, but it is already powerful enough to transform workflows, software, marketing, customer operations, and content creation. And the organizations that benefit most are the ones that combine AI capability with structure, measurement, and human judgment. If this helped you understand AI more clearly, keep following ZeroEmbed for more tutorials on AI learning, automation, and AI workflows. You can learn more at www.zeroembed.com or reach out directly at connect@zeroembed.com.